Hey everyone, welcome back, and today let's solve Leetcode problem 44 titled Wildcard Matching. So we're given an input string S and a pattern P, and we have to implement wildcard pattern matching with support for the two special symbols, question marks and asterisks, where question marks matches any single character, and an asterisk matches any sequence of characters, including the empty sequence. So the matching should cover the entire input string and not just partially. So honestly, it's a pretty difficult problem statement to actually digest at first. And so when you actually look at the examples, it becomes a little bit more clear on what the problem statement is actually asking you to do. So in example 1, we have an input string S to be AA and a pattern to be just 1A. And we'd output false because A does not match the entire string AA. And since we don't actually have these two special characters of question marks and asterisks, we can't actually change the value of the pattern, and so we just have to directly compare them because that's the only operation that we can do. And since A is not equal to AA, we'd output false. So in example 2, we have the input string S to be AA and P to be the asterisk, okay? And we'd output true because, as we saw before, the asterisk is defined to be matching any sequence of characters. And so we could actually change this asterisk to match AA by simply replacing it with AA because that is a valid sequence of characters. And since AA is equal to AA, we would output true. So in example 3, we have the input string S to be CB and the pattern to be a question mark and then A. In this case, we'd output false because although we know that the question mark can match any single character, we know that we could change the question mark to be a C. But even though that question mark could match C, the second letter A would not match B. So for that reason, this would be still an output of false. So with that out of the way, I will give you guys a few seconds to kind of just go over this problem in your head and think of a valid solution, and then I'll show you guys how I would optimally solve this problem in a bit. Okay, so to be honest, this is a pretty hard problem, and so I think I'll just give you guys a quick rundown of how we're actually going to approach this problem and the way our algorithm and solution is actually going to be structured. So if you guys haven't picked up yet, we're actually going to be using dynamic programming to solve this problem efficiently, right? So for the dynamic programming or DP table, we'll actually use a 2D Boolean array. We'll call that DP, where DP at index I, index j represents whether the first I characters of the string S match the first j characters of the pattern P. And for the size of the DP table, that's going to be initialized to be m plus 1 by n plus 1, where m would be the length of the string S and n would be the length of the pattern P. And that's because we also consider empty strings and patterns, and so we'd actually have to also account for when we have an empty string and an empty pattern. And so instead of our dimensions being m by n, to account for that empty string pattern, basically our base case would have the dimensions to be m plus 1 by n plus 1. So for the initialization, we'll have DP at index 0 to be true, because of course an empty string always matches an empty pattern. And for any DP at index I at index 0, that's going to be initialized to false, because when I is actually greater than 0, no non-empty string can actually match an empty string. And so that would be all initialized to false. And for DP at index 0 index j, where j is actually greater than 0, that's going to depend on whether the pattern contains only asterisk characters, since an empty string can actually match a pattern of multiple asterisk characters. So for the DP transitions as such, if P at index j minus 1 is a question mark, or S at index I minus 1 is equal to P at index j minus 1, then DP at index I index j is going to be set equal to DP at index I minus 1 index j minus 1 because they match character-wise. But if P at index j minus 1 or the pattern is an asterisk, we have two options. We can either consider the asterisk as a matching of 0 characters, so basically, for example, DP at ij would be equal to DP at ij minus 1. Or, for our second option, we can consider the asterisk as a matching of one or more characters. So, for example, DP at ij would be equal to DP at I minus 1j. Okay, sorry. Turn off my screen. Okay, so essentially here, we actually have to use that dynamic programming approach to actually populate and update every index in this 2D Boolean array to actually check if we can actually match the pattern with the string. So we'll start by actually storing the lengths of the input string s and the pattern p in the variables m and n respectively. So I'll literally just say m and n is going to be initialized to the length of s and the length of p. Again, we're storing the length of input string s and the length of the pattern p to be stored in variables m and n respectively. And so this is actually going to enable us to easily access them later, so we can actually initialize them to be the dimensions of our DP 2D dynamic programming table or array. So now we actually have to initialize our dynamic programming array. So I'm going to initialize that to be an array of basically false times n plus 1. Again, where n is the length of the pattern. And this is going to be set to this for every single range. I'll just use an underscore for my placeholder for this iterator, so for every blank in the range of m plus 1. And I'm going to actually set this to be a complete array, so I'll wrap this all around in an array or list keyword. So again, essentially what this does is we're initializing this 2D list DP of size m plus 1 times n plus 1. And all the values are initially set to false, and this list is going to store whether the substring of s up to index I matches the substring of p up to index j. Okay, so for our base case, we'll set dp at index 0 like we talked about before to be initialized to true, which in Python is actually capitalized, the true boolean keyword. And that's going to be, since an empty string matches an empty pattern, we obviously will set dp at index 0 to be true, kind of like our base case essentially. So now we actually have to iterate through the pattern p. So the way we do this is we'll say for j, like the indice or iterator like we were talking about before, so for j in the range of from 1 until n plus 1, where n is the length of that pattern. And then now we actually have to check if p at index j minus 1, if p at index j minus 1, if that's actually equal to the string of an asterisk, then we know that dp at index 0 at index j can actually be updated to be dp at index 0 index j minus 1. And why do we know this? So when we iterate through this pattern, if we actually encounter an asterisk at position j minus 1, it can actually match the empty string. And so for that reason, we'll set dp at index 0 index j to the value of dp at index 0 j minus 1. Okay? So now that we have that out of the way, after we actually loop through that pattern, now we actually have to loop through every single value or element in the range of, I'll say I as our index, like we talked about before, in the range of from the first element or pattern till m plus 1. Okay, m plus 1. Now I actually have to check for j in the range from the first element till n plus 1, where m and n are the lengths of input string s and pattern p respectively. Again, what this does is this nested loop is going to fill in the rest of the DP table, where the outer loop iterates through the string s and the inner loop iterates through the pattern p, with our indices or iterators, as we talked about before, to be I and j respectively. Okay? So for this nested loop to cover through every single element within these two patterns and input strings s's and p, now we actually have to check if p at index j minus 1 is equal to a question mark. So we'll say if it's equal to the string of a question mark, or s at index I minus 1, if that's actually equal to p at index j minus 1, then we know that we can set dp at index I at index j to be updated at dp at I minus 1 and j minus 1. Okay, now this is the most crucial line, because it says that if the current character in the pattern is a question mark, or if it matches the current character in the string s, we would set dp at index I index j to dp at index I minus 1 j minus 1, because that means that the current character in both s and p are a match. Okay, so that's exactly what that does. And we'll have another else if conditional in Python that's going to be just elif. Elif, and that's going to say if p at index j minus 1 is actually equal to the current element of an asterisk that we're looking at in this iteration, then we can set dp, at index I at index j to be dp at index I, index j minus 1, or dp at index I minus 1, index j. That's also very important. And essentially what this is saying is that if the current character in the pattern is an asterisk, we can set dp at index I, index j to true if either dp at index I, j minus 1 is true, indicating that the asterisk matches 0 characters, or dp at index I minus 1j is true, indicating that the asterisk matches 1 or more characters, which is very important. And essentially, once we actually exit this nested loop, when we actually iterate through every single element in both the input string S and the pattern P, we can literally just, after we exit that, return dp at index M, index N, and essentially this is going to indicate whether the entire string S matches the entire pattern P, where M and N, again, are the lengths of S and P, respectively. So unless I made any syntax errors here, this should actually be accepted, and this should actually work. But it probably spelled something wrong. But no, it looks like I didn't. And as you can see, this is just about as efficient as you can get. So again, to better explain what this does, because if you guys didn't understand yet, essentially what the overall code does is it constructs a DP table that keeps track of whether different prefixes of the string S match different prefixes of the pattern P. And by considering various cases, whether the current pattern is in question mark or an asterisk, or a regular character, this algorithm or DP algorithm updates the DP table accordingly. And once the table is fully populated, the result stored at index mn in the DP array table tells us whether the entire string matches the entire pattern, right? And note that every single element or cell in this DP array is going to be a Boolean value, right? So for the time and space complexity here, the time complexity is going to be big O of m times n, where m is the length of the string and s and n. M is the length of the index of the string s, and n is the length of the pattern p. And this is really because we'll fill out a DP table of size n plus 1 times n plus 1, and each cell is processed in constant time. Right, and for the space complexity here, the space complexity is also big O of m times n, because obviously we'd actually need to store the DP table of size n plus 1 by n plus 1, right? Because we actually need to check for every element if it's a Boolean value or not at that specific indice when we're actually mapping or matching it with the pattern to the input string S. So hopefully that kind of cleared up how this problem is actually structured and how the dynamic programming algorithm actually works for this problem. And again, this is a pretty hard problem. So what I like to do when I struggle with problems like this is take the code that you have and actually apply it, right? To better visualize how it works, just apply it to any example you'd like, typically the examples 1, 2, or 3 that I actually provide in the problem, and just see how it actually works and how it actually operates and why that actually works. Right? And that's really the best way of going about this when you don't actually understand what an algorithm or code actually does. So with that out of the way, if you guys enjoyed this solution, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye-bye.